Hello everyone and welcome back. This is episode 5 in my Pygame series, and in this video I'm going to be showing you guys how I managed to do the collision detection system inside of this game. Now in the last video I was just showing you guys that I had some laser mechanic working, and also I built in on top of that and adding some collision detection, and I started doing this through using a feature in Pygame called masks. And before I get into that, I'll just show you what I've done so far. So as you can see here, you can see the enemy is shooting some lasers. I'm still trying to make sure that works. However, as you can see, whenever I shoot the laser, it registers whenever I hit the enemy, and then it takes the laser out of the screen. So the way I've accomplished that is by I should quickly delete this. Okay. So the way I accomplished that is by actually keeping a list of all the different I kept a list of all the different lasers which the ship has, and then whenever the player shoots a laser, I will then check if that. I was going to keep on iterating over all the lasers inside of the laser list, and then I'm going to increase their Y coordinates, and then once they have reached a certain point on the screen, so if they hit an enemy, I'll check for collisions. So if they hit the enemy, I'll pop them off the list, so they'll be taken off the screen. Or if they have hit the let's say one of the edges of the screen, they'll also be taken off the screen. They'll also be popped off the list, which will take them off the screen. So if I go down here, we should be able to see it. Here we go. So laser list right here. This is containing all the lasers inside of the laser. So it contains all the lasers which are on the screen for each enemy and for the player. So the way I designed this class is that I can use the same class for the player ships and the enemy ships. So I'll show you guys this part here first about the enemy ships. So whenever I run this program, you'll see that I have a different enemy ship appearing. And the way I did that was just by, if I go back here, is that I've made in this main class right here, in the file called main, I have this class called main, and in there I've defined this variable called enemy ships. And if I just go over here, let's go there. Nope. Okay, let's just go to it. Main. So here I have, if you can find it, it should be around here. Here we go. So it's after enemy ship. So this is a dictionary, and it contains a string which is going to be the ship, and then if it's a blue ship, it's going to have the blue ship image for the actual ship itself, and it's going to have a blue laser, the image of the blue laser as the image of the laser. And it's the same for the green ship and the red ship. And then what I did is that if we go down here again, where was it? There we go. So what I did was I'm just selecting I'm using a random library inside of Python to select a random value from this dictionary, and then whatever that value is going to be, I'm going to set the enemy image to be the first element of that list, and then the enemy laser to be the second element, because if you see here, this is actually a tuple, technically it's a tuple, and then this is the 0th element, this is the first element, and they're arranged that way. So the ship's image is first, then the laser image is second. So I just use that to randomly generate it, and then just put this on the screen. And then here we go. So I've got this function here called draw enemy ship, and then it will just draw the enemy ship with the enemy x and y coordinates. And then the enemy ship movement, I think I showed this in the last video. I don't think I've actually added anything to it. So if we go down a bit more, we should see the collision part. So if you go back here and quickly not this one. Let's go to the main. Space Invaders.live. Let's run it. So as you can see, the way the collision works is that I'm actually using something called masks, and the way masks works is that it will essentially check whenever the pixels of the actual image are colliding with each other, and this gives you a lot more. It gives you much more accurate. That's just how I would say a much more accurate collision message, if that's the way to say it. So it'll be much more accurate than what I would usually do, just using a bunch of boxes and checking for collisions if the boxes are colliding. But the boxes are usually bigger than the ship's image, so it's not really that accurate. So oftentimes the player might just be moving across the screen, and then the bullet has not even hit the player's actual image, but is intersected with the box, so a registered collision, which is not really that accurate. So this function right here, this method called collision takes in a bunch of arguments, and this is because I wanted to be able to use this for the enemy ship and the player ship. That takes in the first object's image, the first object's x and y coordinates, the second object's image and x and y coordinates. And then here it uses two methods from Pygame called Pygame.mask from surface, and then I give the image of the first object, and then I made these, and then I made a mask from it, and then did the same with the second image. And then I calculated something called the offset. I'll get into this in a second. But then the offset is basically the distance between the top right hand corner of the enemy and the... so it's basically the difference between the enemy's position and then the player's position. And then for collision, I'm just checking if those two masks overlap, and if the collision variable is not going to be equal to none, so is actually equal to a value, which means other than none, it means that the collision has taken place, I can just say, well, return true, and then I'll handle that somewhere else to decide what to happen. Now, these masks and offsets, they're quite difficult to explain without really giving a visual representation of it, so I'm just going to open up Paint here and then show you guys how it works. So, first off, let's just say we have two players on the screen, so I'll do it this way. So we can have one player be one triangle, we'll make him yellow. Actually, no, let's just make his fill yellow. Oh, that didn't work. Let's do that. And then we'll fill it with... I'm so confused, okay, it's not working. So that's going to be that color, and then this other player is going to be blue, let's say. Now these two things are actually just images, or Pygame treats them as images, and each image is going to have transparent pixels and pixels which are colored in. So if I actually show you how an image will actually look like, it will look something like this. So let's put this mix back. So these pixels inside, the rest of the pixels which are outside, they're going to be transparent pixels, and then these pixels of the actual image you want the player to see are going to not be transparent. They're going to have a certain color, and they've got certain values attached to them. Now, what Pygame does to be able to use masks is that it will essentially make something called a mask out of this image, which is essentially going to be this image but represented in ones and zeros, if that makes sense. So let's just say we're going to split this image into a bunch of pixels, so I'll just draw a bunch of lines here. Yep, they're not really that good. Let's just say that this is all the pixels in the image. Okay, so let's just say these are all the pixels in the image. It probably isn't, but let's just say they are. And wherever the actual image is, we're going to say that, so let's just say this one here, so let's use orange. So this pixel here, right here, it has, no, I want to use a paint. Let's use brush, okay. So this pixel here is colored, so I want it to have a color. This one also, this one as well, this one as well. And then I want this pixel, that pixel, and this last pixel here. So all these pixels, they have colors. The rest of these pixels, they don't have any colors. I don't want them to have any colors either. So I'm just going to say these are all going to be transparent pixels. So what Pygame does is, okay, so all these transparent pixels, I'm going to give them the value of 0, which means that they are transparent. So all of these will be 0, 0, 0, 0, 0, 0. And all these pixels which actually have a color, that means assigned a color, I'm going to give them the value of 1. So let's just say it's going to be 1, 1, 1, 1, 1, 1, 1. So this mask is essentially that. So if you go back over to here, you'll see that this object 1 mask is just literally this. It's just getting the image and making a mask of ones and zeros out of it. Zeros being the transparent pixels, ones being the pixels with actual colors or values. And then this other part here is the offset. Now, what this offset is that, well, the actual, when I say like the enemy's this image, so is position on the screen is X and Y, is recorded by the top left, so yeah, the top right, well, is my left, so I'll say the top left hand corner of the box, so I'll just draw this here. This top left hand corner represents the X and Y coordinates of this image. So when we draw on the screen, we are actually just it's drawing it from this point here of the image. So that's why we like whenever we want to check for collisions, we can't just say, well, is the X and Y going to be on that side of the screen or that side of the screen? Sometimes have to do some more complex stuff to get it accurate. But this is the X and Y coordinates on the screen. Now what the offset is, it's just the distance between the first objects or the first images placed on the screen and the second objects placed on the screen. So in the case of masks, this is literally just the this is literally just like the distance between these two mask images. So I'll draw a line here and I'll make this line, let's just do green. So this is going to be that, and then I'll also write down, nope, I want this to be green. And then I'll draw a, I think this is the X and Y coordinates of this one as well. Okay, so this line right here is going to be the offset. I'm just going to type this down instead. Offset. Let's make this a tiny bit smaller. Okay, that didn't work. Okay, this is the offset. And then what we can say is that this offset, we can calculate it by subtracting the X coordinates of both of these images and the Y coordinates of both of these images. And what we're doing is we're just checking that, okay, when are these two images intersecting? So if I drew this diagram once again, okay, so let's just draw this diagram once again. We're going to have our two players again on the screen. We're going to make all these boxes black. This is our second one. And let's do it this way. We're going to have our player here. Let's just use the triangle again. What was it? Okay, bro. What color is this? Okay, blue and yeah, orange. So this is our first triangle here. Let's say move it up a bit here. Make it blue. And it's gonna be a second triangle over here. And then let's just say we made him orange. I think that's it. So what we're doing here is that these two images, the masks are of the images are intersecting, but this also means that the masks are going to be intersecting as well. So if I drew these lines once again, let's just make them all black. I'll just do a really bad job of it just to do it. Let's get it done quickly. Okay. Then the back of it here. And then we'll just draw the horizontal lines for the pixels. This is a very messy diagram, but hopefully it makes a bit more sense now. So, okay, let's just finish it off. One more line, and that's it. Okay, so let's just imagine that this is going to be the pixels for this image. It's going to be the pixels for that image. Now, as you know that these values here, okay, I have to get the line tool. So these values here are all 0, and we know that is all 0. However, these colored values here, these colors, they all have a value of 1. So let's color this one in here as well. These are all 1. Now, the thing is, that, when we're doing mass collisions, so let's give all these values 1, and then these are all 0, 0, 0. Now, okay, so here when we're doing the collision, we're saying object object 1 mask to overlap with object 2 mask, and we're giving the offset. Now this overlap method in here is just checking if these two masks, so these two 1. So actually let's explain this. So whenever we're doing collisions with overlaps in masks, what we're just doing is we're checking, okay, if these two these two pixels with a value of 0, if those two things are colliding or intersecting, we don't really care. However, if these pixels with the value of 1 are colliding, so the actual pixels with the colors inside of them, if those ones are colliding, we do care, and we're going to say that we're going to return the point of intersection. So we're going to be returning the first point where these two images collided. So that in that case, it'll be around here-ish, I think. I'm not sure. So they're just returning this point of intersection. Actually, no, I'll just type it down. Point of intersection. Let's make this a lot smaller. That's a lot better. There you point of intersection. Why is that over there? Let's take this. Let's bring it down over here. Okay. So we're checking for this point of intersection, and what this means is that we get extremely accurate collision detection, because we're getting the exact point where these two images are colliding. And then what's happening is that we're saying that, okay, if this first object right here, the mass of the first object is overlapping with the mass of the second object, and then we're going to give the offset, which we have calculated up here, to be the difference between the x and y coordinates of object 1, the object 1, object 2, and the y coordinates of that object 1, object 2. So this is going to return to us the point of intersection. Now the problem is, I can't just say, well, okay, if collision is going to be equal to collision is going to be equal to this certain point, let's just say 10, 20, I don't know, and then, like, you know, return true. You can't really do that, because we don't actually know what it's going to. We can't actually predict it. It can be any coordinate. So we're just going to say, okay, well, we don't know what it's going to be, but if there's be no collision, it's going to be equal to none, right? So we know it's none. So if it's not equal to none, I just want you to return true, and I'll handle the rest of it outside of there. And that allows us to make sure that we have checked for collisions. Now, if we go down again, and then we look here, okay, so we're just checking for collisions. So I'm just saying, if the ship type, which I have defined, okay, this is not working for some reason. Okay, so the ship type right here, if it's equal to 1, then I want to pop the laser list of this index. So if it's 1, then that means it's going to be the actually I can't remember. Let's go up here and check again. Ship type, let's do. Okay, so if ship type is equal to 0, okay, here we go. This is it. So if it's an integer 0, 1, if 0, the ship is going to be enemy ship. If 1, it's going to be a player ship. So here we're saying that if it's a player ship, I just want you to pop that list, pop that thingy off. Sorry, I meant the laser off, the laser list. And then if it's going to be a enemy ship, let's return true, and then handle it somewhere else. And then, well, this is not for me. I was trying to move all the stuff up here to go down here, but I don't think that's necessary, to be honest. So we'll just get rid of this. Okay. So let's go back there and we'll run this again. So now this probably makes a bit more sense. Now you're probably asking, well, what about these enemies shooting lasers? Well, to be honest, I haven't actually completed that myself. I'm still working on it. I have this weird, well, kind of hacky method to get it working. It's barely working. It's got a bunch of bugs with it, so I'm planning to fix that. And well, that's basically it. I'm also planning not to really take this project on anymore. I'm planning to learn and move on to making games using Unity, and then I'm going to move on to learning C++ and then making game engines. So this is probably the last video in the series. So I hope you guys enjoyed it, and I'll leave a link to the GitHub repo in the description below. I'll just push all these changes over to there so you can see all the stuff there. And that's really it. So thank you for watching today, and I hope you enjoyed the video, and I'll appreciate it if you gave this video a like and subscribe to the channel. And other than that, bye.